This Booster BIM video shows how to use the Revit API to create an associative relationship between beams and edges. Using the Revit user interface, we can create beams using the pick line command. However, the resulting beam has no continued relationship with the geometry used to create it, and in this case, when I move the floor, the position of the beam does not update. Here, a Revit API command has been written that will prompt the user to select edges. We can pick either a straight or curved edge to create beams based on those edges. If we look in the project browser, we can see that information about the edge used to create that beam has been stored in a parameter of the beam. Now, when I edit the floor slab, and I'll change the radius of the arc, and I'll change the length and position of the straight edge, I can then use the API to update the geometry of both beams. The information about the edges does not need to be stored in this user visible parameter. Instead, it could be stored using extensible storage or using a hidden shared parameter. Additionally, instead of having to run a manual update command, that could be done automatically using the dynamic model update API feature. However, for this proof of concept, the current implementation gives you an idea of how this can be done. For the creation of the beam, we first will find the symbol, which in the API corresponds to the type in the user interface, of the 12 by 26 beam. That's the type of beam that will be created after the user selects the edge. In a fully developed application, some user interface would be likely desired to allow the user to specify which family and type of beam to create. Next, we use this filtered element collector and link statement to find the lowest elevation level of the project. This is needed because the beams have a reference level property, and we need to specify that when the beam is created through the API. Next, we'll prompt the user to select an edge using the pick object method with an object type of edge. With the reference to that edge, which is returned by the pick object method, we then will get the element, which in this case is the floor, and then get the edge using getGeometryObject from reference and passing in the reference that was selected. Now we start the transaction to create the beam using the new family instance method. From the edge the user selected, we get its curve, which we passed in as an input to specify the geometry of the new beam, and then specify the beam symbol found above to specify the family and type of the beam, the level, and that the structural type of this family instance will be a beam. Next, we'll find that parameter that I've called beam reference for this example, and in that store information about the edge that was used. We do this using the convert to stable representation method of the API. We can see here in the help file that this will convert the reference into a stable string that can be used to represent this reference. And the value of this parameter will be something in the form shown here. If the parameter does not exist, we give this error message, and if it does, we set the value as shown here. In an upcoming video, I will discuss the update all beams on edges method that was used to then update the geometry when the edge geometry has changed.